I'm Konstantinos Vasilakos. My project is called Lick the Toad, and apropos to the theme of this conference, I named this presentation From Craft the Code to Lick the Toad. So this is a project that I've been working for a while now, since 2021, and Lick the Toad, originally it was created as project, as an installation project with using mobile devices. And actually the first iteration of this project was presented in NIME 2021, I believe in this room when NIME took place in this university. So the idea is that so that was an installation actually, and then I expanded it to live coding, which is kind of working right now. So it's a little bit of work in progress on expanding on the live coding idea. So this is a network music system using neural networks regression algorithm trained by multiple users and sonified using live coding in SuperCollider. The link to the first version of the software itself is at this address, and the deployed version of the project is at this link. Before I move on, I will just say that I'm not a neural network or machine learning specialist, nor a networking engineer. So my understanding and my knowledge working with sockets, servers, and how to exchange data became expanded on this very recently. So the interface looks like that, and it runs on mobile devices or in laptops as long as you're on the same network with the application, with the server running, with a computer running the server on the same ad hoc network. So it looks like this. Not much here to explain, but I will go through gradually of how it's working. So what's the aims of the project? The aims is to use machine learning operation with users' input data and output for coherent sound making, because I think Scott also mentioned this work with Peer Ensemble that was a part of doing my research in the UK and working with Scott, as he mentioned a couple of times. And the problem with laptop ensembles is that they're great, but the members, most of the times, they do whatever they like, and that creates a problem of having a dissonant outcome. Another aim is that it's an interface for collection of data to import in neural network, and also the interface provides visualization and sonification of the predictions to engage either with other users in ad hoc stages, at the same time combining sounds generated by the audience and the performer. Also, it provides bidirectional communication between users and the coders using open sound control. So part of this project also is an interface, a very small interface that I developed in SuperCollider, which is used for selecting incoming streams of data and events allocation based on each user's ID. A little bit of background, to be fair with people who already did work on the area and to provide some kind of a context of my work. So I think that could be arguable, of course, but I think one of the first attempts of the humanity to use decentralized systems to communicate what they do, probably it falls really long time ago, from Elisha Gray, 1874, with a musical telegraph or electroharmonic telegraph, where it says, quote, one of the inventors of the telephone had developed a way of transmitting pitch tones over a long-distance telegraph network using electromagnetically controlled and vibrating metal reeds. So that's kind of inspiring of what we do with telecommunications today. Arguably, of course, someone can say, well, that's totally different approach, but trying to give some kind of context. Of course, many others followed. The telharmonium, which was also a huge instrument, probably 3 times of your refrigerator at home right now, where people had to change in real time many devices in order to keep it going. In other parts of Europe, Téléphone Hirmondo, and the Theatrophone in France, and probably in the UK around that times. So having a little bit of time jump, in the meantime, network. So people started using networks 1978 probably, at least that's something that I am aware of. In my best knowledge, the League of Automatic Music Composers, the idea of using a network as a music performance strategy, and probably whoever is in live coding is very well aware of the Hub computer ensemble that was founded in San Francisco Bay in 1986. So coming to nowadays, and huge leap forward, I mostly find myself being in the context of laptop ensembles, also mostly because I've been working with Scott Wilson for years now, doing sonification projects, namely the CERN project, etc. And but it's a small community, so it's not like I differentiate from others. So I would just put myself also in very close proximity with Cybernetic Orchestra, David Ockborn, the Beer of Scott Wilson, and the Power Books Unplugged, namely Alberto De Campo and the rest of the gang from Berlin. So that's a little bit of context of where I'm standing in terms of aesthetics. Now, the other idea that I wanted to explore with this project is the audience participation, because I think live coding is great, but is a little bit of a isolated practice, like any other music performance strategies we know so far. So what I wanted to engage, what I want to explore is how can I engage with my audience in a more dynamic and a more tangible way. For example, I think jazz musicians, they use very good idea of communication. Real time is jazz musicians where they just use their hands to show the head, to go back to the verse and things like that. But still, all this, it's in a very stochastic way. So with networks now and data, we can actually share explicitly what's going on amongst the audience and the performers. So some background of other people have already researched about audience participation. It comes from Anna Hambo et al. Hedl, excuse me, my German or Austrian pronunciation might be a little bit offending, but the last one is Frederick Vasilakos. All these references are at the end of my presentation, also on the full paper. And Diego Dorado, live coding with emojis, which I find myself very much resonating with the idea, but using a little bit of different strategy. So I have a video to show how the users can train the interface and start communicating. There's no sound on this because it's just a screen recording, but there will be sound later. So on the side, oh wow, that's very fast. Why? Normal. Okay, let's make it smaller. That's extremely fast as well. I don't know what's going on. My computer wants to finish faster than I do. Anyway, I hope you get the idea. So, what is the development? What's the implementation? What kind of tech I'm using? So, the communication between clients and servers is bound through WebSockets, and I'm using Express for server. And the data from Toads to SuperCollider, I'm doing it through OSC.js library. It's all written in JavaScript, by the way. It's a Node.js application. It runs locally with Node.js and online, but at this moment, the user's OSC data is only supported locally until I find a way how to do that online. remotely. The sound synthesis of toads is using Tone.js and Markov chains extension for JS. One thing I didn't mention is, although I'm sonifying the neural network data and machine learning and the model that is actually trained, on top of that, I'm using a Markov chain to create a little bit of more variation of the data of the users instead of falling on the same data all the time. So the strategies and I'm using through live coding is focusing on the real-time sonification of the incoming data. The coder is mapping these values in running processes with the help of streams and patterns of SuperCollider. Whoever is a SuperCollider user knows about patterns and streams very well. And each user is sending their data in an array of nodes as well as raw digits. So a PDF here, it's actually created using the user ID, which the user ID comes from the server. It's the first line of the code, and then the code is actually automatically embedded and rendered inside the PDF. So I don't have to do anything so far in terms of coding, but this actually this mechanism is actually facilitated by the interface I built in SuperCollider. Excuse me. So more into the live coding process, the selection of data on the fly is through by the way, this is the form of the OSC messages that I receive in SuperCollider. So it's just an array, raw frequencies in SuperCollider by each user. And also at the same time, the users can see this on their interface. I don't need to use the notation because as a live coder, I don't think I have a use for notation. What is useful for me is the raw data. So interfacing with SuperCollider, this is just a GUI which actually shows me activity with the users. Each time a new user is sending me something, the GUI name of the window is actually showing the user ID. And then it changes according to their data. And then here is the window which actually can select the user ID key on top and the PDF which is actually rendered from the function SuperCollider. So I have a tiny, I wouldn't call it even a language. I would be embarrassed to call this a language in ICLC conference. It's just a way to trigger things. So I have made some collaboration between, I said in the beginning, is a bidirectional communication with the SuperCollider and the server, which actually triggers everyone's users' functions. So the function of Markov train here and the OSC trigger. So that's very ideal when people are lazy and don't want to do anything. So I can just hack their devices and generate more information for me. At the same time, it's not limited to SuperCollider only. I recently found a way to do it also in tidal cycles. So I'm using SuperCollider as a forwarder, OSC forwarder, and then I'm getting everything from the Node.js server, sending to SuperCollider and sending it to tidal cycles with a little bit of treatment. So this is the forwarding mechanism. And then I map this inside my tidal cycles code, which in this instance I can control the speed, which I guess everyone understands what that means. Music. So this is, instead of just rambling more about what I've been doing, I think it's always a better idea to show how it works, and then I think my presentation will come to an end.
Wow.